Today, we are going to explore a common question. What is the difference between a CPU and a GPU? We'll look at what each one is, what it does, and why it matters so much for artificial intelligence.
You've probably noticed that some things you do with AI are almost instant, but other tasks, like asking it to generate a new image, can feel a bit slow. And this can happen even on the very same computer.
Well, the reason for that difference isn't usually the AI software itself. More often, the answer is in the computer's hardware.
So, that gets us to the main question here, understanding the different jobs that a CPU and a GPU are built for. Once we see that, it will be very clear why AI depends so much on one of them.
Let's start with the basics. A computer really has two main processors inside, and each one offers a different kind of power.
First, there's the CPU, which stands for Central Processing Unit. You can think of the CPU as the general manager of the computer. It's designed to be flexible and handle all sorts of different tasks, one after the other.
And second, we have the GPU, or the Graphics Processing Unit. The GPU is more of a specialist. It's built to do one thing really well: handle thousands of very similar calculations, all at the exact same time.
So you can see they're both powerful, just in very different ways. It's not that one is better than the other, they were just built for different kinds of jobs.
All right, let's look a little closer at how their designs affect the jobs they are good at. This is really the key to understanding their role in AI.
A CPU works in a sequence, step by step. It's fantastic at complex logic and switching between different kinds of tasks. That's what makes it so good at running your operating system and all your apps.
A GPU, on the other hand, works in parallel. It does the same simple task over and over again, across a huge amount of data all at once. So instead of one really powerful worker, it's more like thousands of smaller workers all doing the same simple job together.
And this parallel approach, well, it turns out to be a perfect match for many AI tasks. For instance, training an AI model requires millions upon millions of repetitious calculations. And that is exactly the kind of work a GPU is designed to do.
And this brings up a really important point. A GPU isn't smarter than a CPU. It's just that its design is better suited for the kind of repetitive math that modern AI is built on.
Okay, to make this a little more concrete, let's walk through an example.
Let's say you ask an AI to create an image based on a description you write. To do that, the system has to perform millions of similar calculations to figure out the color and placement of every single pixel in that image. Now, if a CPU does this work, it might take about 30 seconds, because it's handling those calculations one after another. But a GPU can do that same job in about 5 seconds. That's because it's working on many pixels at the same time, which results in a huge speedup. And again, it's important to remember that difference in speed is not about one being more intelligent. It's simply a matter of design fit. The task was a perfect match for the GPU's strengths. This leads to a key idea. In any modern computer, these two processors don't really compete with each other. They're designed to work together. So, to quickly summarize, CPUs are great for handling lots of varied tasks and complex logic. GPUs, on the other hand, are the experts at repetitive work that can be done in parallel. GPUs do have their limits. They aren't very flexible for general, everyday computing. And that's why the CPU is still absolutely essential to making the whole system run. A simple way to see their relationship is like this. The CPU acts as the coordinator for everything, and when a big repetitive job comes along, it hands that work off to the GPU to do the heavy lifting. Now, it's important to be clear that this was a high-level view. We focused on the main idea here, and we haven't gone into the deeper technical details of hardware or specific AI models. So, if you only take one thing away from our time together, I hope it's this. AI tasks run faster on GPUs, not because GPUs are smarter, but simply because they are built for the exact kind of mathematical work that AI needs to do.
Thank you for listening.